Hey guys, and welcome back to day 11 of our daily interview algorithms. So today we've got another nice and simple one, but the core concepts are really important. And this is to basically calculate the minimum perimeter of any rectangle. And so a perimeter is basically the total of the outside lengths added together. So here's an example. If you have an integer n, so that would be where the long lengths are equal to 30. So you would have two lengths and two widths. So 30 times 2 is 60, and then you would have the width. So 1 times 2, which is 32. Which is 62. So this algorithm, basically what you want to do is you want to check to see which numbers can be divided without creating a remainder to calculate the two factors into n. And then you want to basically calculate the perimeter using those two numbers, and you just want to keep going through every possible combination. So you can do this actually pretty simply with a for loop. So what we'll do is we're first gonna create a for loop. So for, and we're gonna be starting at 1 and then just working our way up to n, which is whatever value we're given. So as long as x is less than or equal to n, you want to increment x. Now what we're going to do is every time we're going to check to make sure that x, that n actually, if it's divisible without any remainders, then you know that that is a factor of n, so we can use that. So what we will do is just make sure that if, so first we're going to calculate the perimeter, so that would be x times 2, so the two long lengths times 2, plus the remainder, so that would be, let's see, so n minus n divided by x times 2. And if that holds true, then what we want to do is we want to have a max count variable and set it equal to this total value. Now we haven't got a max count variable here right now, so what we want to do is var max count equals, and just to start off we're going to set it to n times 2 plus 2, because that's going to be the maximum perimeter. And what we want to check is if the max count is less is more. So if the max count is currently greater than our perimeter that we've calculated, then we want to set the max count to the perimeter. I think it's better if we rename this to min count actually, because we're getting the minimum. And we're going to give that a quick run. And obviously we're going to fail because I just realized we're not returning anything. So what we want to return is return min count. And if we run that again, okay, so we're missing a symbol somewhere. So for unexpected symbol, and that is because okay, over here. So what we can do is just over there, semicolon. Okay, and that's because we haven't renamed that. You can see just how many errors we go through, and we are successful finally. So we're going to submit that. And again, if n is quite a large number, because we have to iterate through every single value, this can affect our time-space complexity quite exponentially, so our performance is going to suffer a lot. And again, it's not an ideal way of doing it if you're using a for loop, but it is just one working way. So I'll definitely advise looking into other possible ways of doing this. Okay, so as you can see, we are 100% correct, but our performance isn't that great at only 40%. So that brought our total score down by quite a bit. And I bet you we've got some timeouts. Yep, so we've got 3 timeouts here. So yeah, this is another issue. You can use for loops. You can get your code to work that way, but your space-time complexity is definitely going to be affected. So thanks so much for watching, guys. We've got another 19 more days to go. So stay tuned, and I'll see you guys next time. See ya.